Hello, my dear students. This is Mrs. Sohir Zaki, and now we are going to start a new lesson in our science curriculum for second prep students. Let's start our lesson. Today is with the title Methods of Heat Transfer. And by the end of our session today, you are going to be able to practically identify the methods of heat transfer, which are conduction, convection, and radiation from or to an object. Also, by the end of our session today and our next session, of course, you will be able to describe the applications of conduction, convection, and radiation in heating and cooling processes using common examples. At the beginning of our lesson, let's start by our lesson preparation and try to study this figure and answer the following questions. In this figure, there are three methods of heat transfer. The fire transfers the heat to the container that contains water, and the boiled water transfers the heat to the handle of the pot. What are the different methods of heat transfer in this figure? This we are going to learn among our session and our next session, inshallah. So we have some questions we want to answer during our lesson. The first question is this lesson, of course, explore ideas that will help you to answer these questions. Our first question is what is the method of heat transfer in 1 and 2? What are methods of heat transfer in these two cases? The second question that we are going to answer, what is the state of matter in which heat transfer with method 2 in the case of the metal handle of the pot? Our third question in our lesson preparation that we are going to think and answer, what is the difference between methods 1 and 3 of heat transfer? What is the difference between these two methods? Let's try to we will take a very simple example from our daily life. We have a cup of very hot drink and we will put this cup in our room temperature. What will happen? You will observe that the drink cools quickly. So when a cup containing a hot drink, its temperature about 70 degrees Celsius is placed in a room at a temperature of 25 degrees Celsius, for example, you will observe that this drink cools down quickly. What is the reason for this? Let's try to explain the reason for cooling down the temperature of our hot drink through our next experiment that we are going to do together. In our experiment, we are going to learn about heat transfer, and of course, in this activity, we will need some materials and tools to be used. And our materials and tools are two glass beakers. Here are two glass beakers, 1 and 2. Tap water, we will use tap water. Heat source, of course, Bunsen flame is our heat source. Thermometer to measure the temperature. And finally, we will use a metal block suspended by a string. So we will use this metal block, and to move this metal block from a beaker to another, we will hang it by a string. Let's start our activity. The first step in this activity, we will put the tap water in beaker 1. So at the first, we will put some tap water here in beaker 1 and record the temperature at the very first step of our activity. So this is the tap water, and we will write down the temperature recorded by the thermometer. The second step, heat another quantity of tap water in beaker 2. So we will put some tap water here in beaker 2 and heat it till boiling. This means the temperature here will be raised to about 100 degrees Celsius. This is the boiling point of the water. The third step, we will immerse the metal block in the boiling water in beaker 2. So beaker 2 has a boiling water, and we will immerse the metal block in the boiling water of beaker 2. The next step, try to predict the heat, the direction of heat transfer. Let's remember the previous step. The previous step was heating the some of tap water in beaker 2 till the boiling point, and then we will immerse the cold metal block in the beaker. So the heat begins to transfer here and heat the metal block. What is the direction of heat transfer? Of course, the heat transfers from boiling water to the metal block. This is our prediction. The hot water transfers the heat to the cold metal block. The next step, transfer the metal block from the boiling water in beaker 2 to the cold water in beaker 1. What will happen? After transferring the metal block from the boiling water in beaker 2 to the cold water in beaker 1, try to predict the direction of heat transfer. So now in this case we have the hot metal block and the cold tap water. The heat then transfers from hot metal block to the tap water. This is our prediction for this step. In the next step, we will measure and record the temperature of water in beaker 1 after placing the metal block in it. We have measured the temperature of tap water in beaker 1 at the beginning of our activity. Now, after transferring the hot metal block from the boiling water in beaker 2 to the cold water in beaker 1, we will measure the temperature using the thermometer in beaker 1. And what you will observe, the temperature raised up. So the temperature in beaker 1 is raised up by transferring the heat from the hot metal block to the cold tap water in the last step of our activity. Is our observation matching our prediction? I think our observation matched our prediction as we discussed. What is our conclusion from the previous experiment? Let's try to study this figure and try to conclude what happens. Here there are two bodies of different temperature, hot temperature and cold temperature. When these two bodies becomes in contact together, the heat transfer from the hot object to the cold object until the temperature of the two objects becomes equal or becomes the same. This is called thermal equilibrium. So, when two non-isolated systems with different temperature come into contact, what will happen? Try to think. Yes, the heat energy, is transferred from the system with the higher temperature to the system with the lower temperature. As in this figure, the system with the higher temperature transfer the heat to the system with the lower temperature, and this what happened when the hot metal block is transferred to the cold water. The heat transferred from the hot metal block, which is the system with the higher temperature, to the cold water, which is the system with the lower temperature. So, the energy that is transferred from one system to another due to what? The difference in temperature. This is called thermal energy. The energy in this case is called thermal energy. Our final conclusion: heat continues to transfer or to flow from the higher temperature to the lower temperature between the two systems till they reach the same temperature. In this case, we will call this case the thermal equilibrium. When the two systems reach the same temperature, this is called the thermal equilibrium. Now evaluate your understanding. We have figure 4, and from figure 4, in which of the three cups is the average kinetic energy of the water molecules the highest? We have learned in our previous lessons that the kinetic energy is raised when the temperature is higher. So the temperature is an indication for the average kinetic energy of the molecules. So the higher the temperature, the higher the average kinetic energy. So we have in this figure cup A, which contains 100 grams of water with 80 degrees Celsius. Cup B, 100 grams of water with 30 degrees Celsius. So, which of them has the average kinetic energy, the higher average kinetic energy? Of course, the higher temperature, which is cup A, in this case, has the higher average kinetic energy. Also, from the same figure, explain your answer. Why cup A has average kinetic energy higher than cup B, as we discussed, as it has the highest temperature. From figure A, choose what is the possible temperature of water in cup C. We pour cup A and cup B waters in cup C. So we have two values of two amounts of water. The amount in cup A with 80 degrees Celsius and amount of cup B with 30 degrees Celsius. What happened when the two amounts are in cup C? What will be the temperature? Is it A 28 degree or 30 degree or 55 degree or 110 degree Celsius. Let's try to think together. The hot water, which has 80 degrees Celsius, will be in contact with the lower temperature water with 30 degrees Celsius. So the heat transfer from the hot water to the cold water until the or the whole amount of water in cup C has the same temperature. So our right answer is 55 degrees Celsius. By adding 80 to 30, we will reach to 110, and by dividing it by 2, the result will be 55 degrees Celsius for the water in cup C. So, in our lesson, as we discussed, we will discuss and explain the methods of heat transfer. What are the methods of heat transfer? The first method is the conduction. And in conduction, heat transfer from one end to the other end through the metallic objects as in this figure. The second method is the convection, and convection current takes place in liquids and in gases when the hot molecules rise up and replaced by cold molecules. This is called heat transfer by convection. The last way or the last method is the radiation. The radiation is a method by which the sun transfers its heat to us to the earth. So the sun is millions of kilometers away from the earth, and space between us and the sun. So the only way to transfer the heat from the sun to the earth is the radiation. So we have three methods to discuss and to explain in our lesson, which are conduction, convection, and radiation. We will start to explain our first way of heat transfer, which is heat transfer by conduction. And of course, we will try to do very simple experiment to learn about transfer by conduction. In this experiment, we will have some tools: a plastic spoon, a wooden spoon, and a metal spoon, and a beaker of boiled water. It's a very simple experiment. We can do it by ourselves, of course, under the supervision of our teacher or even our mother in our home. So we have three types of spoons in our experiment: plastic spoon, wooden spoon, metal spoon, and we will put the three spoons in the beaker of boiling water, and we will observe what will happen. We will do another step. In our next step, we will carefully touch the tip of each of the three spoons for only 1 or 2 seconds after 1 minute of placing them in the water. Which spoons feel hot when touched? So once again, we have plastic spoon, wooden spoon, and metal spoon. We put the three spoons in a boiling water, and we will touch the tip of each one of them after 1 minute. What will happen? What we will feel? What is the spoon that feels hot among these three spoons? And how do you explain this heat transfer based on the particle theory of the matter? Of course, in this experiment, you will feel hot when you touch the metal spoon. We don't feel hot by touching the wooden spoon or the plastic spoon. Try to think and try to explain what happened and why we feel hot only when we touch the metal spoon, but we don't feel hot when we touch the wooden spoon or the plastic spoon. In this figure, we try to explain what happened and what is meant by heat transfer by conduction. Heat transfer in solid objects along the length of the object from one point to another. In this figure, we fix a metal rod and we will heat one end of the metal rod. You will observe that heat transfer from this point, from the end of the rod, to the other point. So heat begins to transfer from here to there. And that is how the heat is transferred through solid object along the length of the object from one point to the other, or from one end to the other. Or, of course, from the object with the higher temperature to the object of the lower temperature. This method is known as thermal conduction. So this is a thermal conduction. Now we will try to explain the heat transfer by conduction according to the molecular theory or the particle theory. In this figure, we have two objects, hot object and cold object. And the dots here are the molecules of hot objects, and the blue ones are the molecules of the cold object. And when these two objects are in contact with each other, what will happen? When one end of a metal rod is heated, the average kinetic energy of its particles increases, causing them to vibrate to greater extent. They are in a solid state, but when they got heat energy, they begin to vibrate more. So what will happen next? Some of the energy of these particles is transferred when they colloid. Colloid means hit each other, or means بتبدأ المولكيولز تصطدم ببعض. So the energy transferred from the particle to the other, to the neighboring particle, which increases. So the particles transfer the energy from the hot object to the very near particles in the cold object. So their kinetic energy begins to increase also in the neighboring particles. In the same manner, of course, part of the energy is transferred to the next particles without the particles moving from their position. So the heat will start from hot object to transfer to the particles in cold objects. So heat transfer by particle vibration from hot object to cold object. Now let's try to do another activity to understand more about the transfer of heat by conduction. Our materials and tools for this experiment: two iron and copper rods of the same dimensions, copper rod and iron rod, metal pins, these are the metal pins, two holders, these are the holders to fix the metal rods, a heat source, of course, a flame, stopwatch, wax. Now let's start our activity. Our first step, we will hang both of the metal rods to the holders in a horizontal way, like in the figure. So we'll fix the copper rod and the iron rod by the holders like in the figure. Our next step, use the wax to attach the pins to each rod at equal distance. So we will fix some of the pins to the metal rods by the wax, as you can see, 2, 3, and 4, 1, 2, 3, 4, and 1, 2, 3, 4. The next step, place the heat source under each end of the rods at the same time, of course, as you can see in our figure, and record the time in seconds it takes to fall one or each pin from the moment the flame is lit in this table. So from iron rod we will record when the first pin falls down, when the second pin falls down, and when the third and the fourth pin falls down. We will do the same for the copper rod. We will record the time needed for the first pin to fall, and for the second pin to fall, and for the third pin to fall, and so on. What we will observe and what we will conclude from this experiment. Our conclusion: thermal conductivity of copper is higher than of iron. We observed that the time taken for the pins to fall down from the copper rod is very fast, while the time taken for the pins to fall from the iron rod is longer than that of the copper rod. So the conductivity, or the thermal conductivity of copper, is higher than that of iron. Now, what is meant by thermal conductors and thermal insulators? Thermal conductivity is a measure for the extent to which a substance can conduct heat through it. So the thermal conductivity is high in the substance that conduct heat much faster than other substance. So in our previous experiment, we observed the thermal conductivity of copper is much higher than thermal conductivity of iron, because the copper rod conduct the heat much faster than the time taken for iron rod, as we observed. The substances differ in their thermal conductivity. Metals are good conductors. Metals conduct the heat very fast. So metals are good conductors of heat and are called thermal or heat conductors. So metals are heat conductors or thermal conductors because they conduct heat in a very good way. So they are all good conductors of heat. On the other hand, substances which have low thermal conductivity, like for example wood and plastic in our experiment, the wooden spoon and the plastic spoon, they are considered poor conductors of heat or called thermal insulators. So the wood and plastic are insulators because they are poor conductors of heat, while iron and copper are good conductors, so they are called thermal conductors. Now let's have an integration with mineralogy during studying some cases like diamond, here in figure 9. Diamond is the best thermal conductor among the natural elements, followed by silver and copper. So remember that diamond have very high thermal conductivity, more even than silver and copper. So our order in thermal conductivity, we will begin with the higher thermal conductors, diamond, followed by silver, then the copper. From our life application, the cooking utensils. The cooking utensils are made of metals, of course. due to their high thermal conductivity. So if I asked you, give reason, we use metals in cooking utensils, you will answer by because they have high thermal conductivity. While the handles of utensils are made of plastic or wood because of their, of course, low thermal conductivity, like here in figure 10, the utensil, this container is made of aluminum, which has high thermal conductivity, while the handle is made of plastic to avoid the transfer of heat to your hand during cooking, because plastic has low thermal conductivity. Now evaluate your understanding and try to solve this question. In front of you, two identical copper cubes. Here are two identical copper cubes touching each other in figure 1. When does the thermal equilibrium occur between the two cubes? The two cubes have different temperatures. This one is of 70 degrees Celsius and the other at the right is 50 degrees Celsius. When does thermal equilibrium occur between the two cubes? Let's try to think together. Yes, of course. When the temperature of the two boxes is equal. So we have discussed before, the thermal equilibrium takes place when the temperature of two bodies in contact to each other are the same. So when the temperature of two boxes is equal, the thermal equilibrium occurs. The second part of our question: what is the expected temperature of the cubes when thermal equilibrium occurs? What is the expected temperature at the end of this activity or at the occurrence of thermal equilibrium? It will be 60 degrees. How I know that the temperature will be 60 degrees? By adding 70 to 50, it will be 120. So the temperature will be 120 divided 2, so it will be 60, as the two boxes from the same material, they are copper boxes and have the same dimensions as well. Our last question about the two boxes: draw the direction of heat flow. So we will try to draw the direction of heat flow during the heat transfer from the two boxes or between the two boxes. Here are the two boxes. The first one is of 70 degrees Celsius and the next one 50 degrees Celsius. So the direction of heat transfer, of course, from the higher temperature box to the lower temperature box. So this arrow will represent the direction of heat flow. This was our last question for this session. See you next session, inshallah. Me, Mrs. Sohair Zaki, was with you today on the live stream platform of Ministry of Education and under the supervision of science consultant in the Ministry of Education. Thank you for watching and listening. Hoping you the best in your life. See you next session, inshallah.